All right. Good afternoon. I'm Ramnivas Laddad. So recently, I worked on a project where we took GraphQL server that was written in Rust and made it possible to deploy on edge computing network, specifically Cloudflare. And we went through that route using WebAssembly as an intermediary. So WebAssembly was supported on that particular platform, and therefore we went with that route. So this talk is about my experiencing what worked, how we had to go about it, how to make it efficient, and so on. I have been involved in many communities and projects. Spring Framework, I was part of the very early crew, Cloud Foundry at VMware, aspect-oriented programming. I'm also a great fan of Indian classical music, and I created a site to help learners of Indian classical music, and that was my first introduction to GraphQL. So that's where we use GraphQL as a way to communicate between server and client. Last few years, I have been working on a project called Exograph, which is a declarative backend for GraphQL. So you deal with your domain model, and then everything else just falls off of it. But before I go and talk about that, let's talk about edge computing. Specifically because there is a subtle difference between serverless and edge. The programming experience is more or less the same. In serverless and in edge, you write a function, and that function responds to some event, such as a fetch. But the difference is, if you look at a typical case of serverless, which is AWS Lambda, you will see that the compute resources are kind of plenty. So you get 10 gig of max memory for your execution, and everything else is a little bit on reasonable size. And it's available, you can deploy AWS Lambda in 34 regions. Now compare this to Cloudflare Workers, which is a typical edge environment. So first thing you will notice is the max memory is 128 meg. That means AWS Lambda support 80 times as much memory. So you kind of have to deal with this constraint. But what you get out of dealing with this constraint is locations. You have almost 10 times locations where your edge computing infrastructure will be sitting. That means your client is likely to connect to a very close by compute resource. The next, little bit about WebAssembly. So WebAssembly at the core of it is a binary instruction format. So if you look at WebAssembly and print it as hex, you will see something like this. Now this is not going to make immediate sense, right? So there is an alternative format called WebAssembly text format. So this is just a translation from that hex stuff to here. So how does it work? Well, for example, I am exporting a function called add, and that translates to 616464. And I'm declaring here that my function, add function, takes 2 parameters, so therefore 0, 2, and 7f for I32, and then it returns 1 parameter of I32. So WebAssembly, however, you don't write code like that, either of the formats. It's fine to educational purpose, but that's about it. It's really used as a target for high-level languages, such as Rust. So how many are familiar with Rust? Oh, quite a few. All right, so you will have immediate clarity on how does it work. So in Rust, you will typically write add function like this. You take 2 parameters and return their addition. If you want to make it available in WebAssembly environment, you will do a couple of changes. One, you will mark it as extern C. That means you are exposing the function and using C calling convention. And you are saying no mangle. That means the name add should not get changed. That means the external system can then go and look it up and execute it. In Rust, if you want to use, now take this code and you compile it to give a target that is WASM32 unknown. So WebAssembly is a portable format. Therefore, you don't need to specify the architecture or platform, so that unknown part. And then you can invoke it. So in this case, I'm using a WASM time WebAssembly execute runtime. So here you say invoke the add function from that particular WASM, passing it parameter 1 and 2, and it will do the stuff and return value 3. So WebAssembly, you run it in some execution environments. It's supported by all major browsers. In fact, the web part of WebAssembly came because that's how it started. But that's not our interest. Our main interest is actually server side. In server side, V8 supports WebAssembly. That means all platforms that use V8, such as Cloudflare Worker or even Node.js, you will have WebAssembly available. It's as a guest. So JavaScript is the main system, and JavaScript system can call WebAssembly, and that's how you can get it. But there are standalone runtimes such as wasmtime and wasmer that allows you to do essentially the same thing. So one of the things you will see in WebAssembly, and you will hear the term called WebAssembly is a sandbox environment. That means by default, you cannot invoke anything in WebAssembly, nor WebAssembly can invoke anything from your execution environment. But that's hardly useful, right? So first thing therefore you do is you expose functions from WebAssembly. And that's where the extern-c add part of it was. That's how you exposed a function named add, so execution environment can look it up and execute. But still, WebAssembly cannot do pretty much anything with the system. That means it cannot open a file, it cannot do a network call, anything. So therefore, the execution environment ends up exposing whatever it feels like exposing. And we'll go through examples of what those look like. And this is a typical setup that you will see in WebAssembly environments. That's also, by the way, underpinning of something called WebAssembly Components, but I won't go into that. Right now, that the green box that you punched in, exposed system execution environment exposed to WebAssembly, is much of ad hoc basis. But there is a standardization effort to make this portable. So you can have system resources such as file, socket, etc., will be made available in a standard format. What does it buy you? It buys you a way to have portable, high-level language code. So in Rust, rather than writing very specifically how the execution environment chooses to expose it, you will have now standard way that essentially, if you're using Rust, then if you want to open a file, then you just use stdfs APIs. The way you compile is you give, instead of target wasm32 unknown, you give now WASI target, wasm32 WASI, and the P2 is for preview 2, which is the latest version of WASI. So let's talk about, with that understanding, Edge and WebAssembly. Let's talk about targeting GraphQL server to Edge. So I'll talk about the project that I have been working on, Exograph. It's available on GitHub. You can look it up. So the idea is you express your domain model. So in this case, I have concert and a venue, and there is a relation between the two and some access control rules. And then you start the server, and you will get GraphQL APIs ready. The way it works is you start with your domain model, feed it into something called Exograph Builder, and Exograph Builder will examine all that stuff, make sure that it's parses and it's type checks and everything. And then it produces something called an intermediate representation, XOIR. And then the Exograph runtime picks it up, and whenever query comes, let's say concert, give me title, ID and title, it will go talk to Postgres or other services and resolve it and return you that data. So let's do a quick demo. So here I have slightly more complicated model. So in this case, I am saying I have this e-commerce. Let me just make it big and bump font. So I have here product, and product can be seen by anyone as long as it is published. But unpublished product can be seen only by admin. So that's the rule for accessing. Similarly, there is a rule for mutation that only admins can mutate it. There is also field level security, which says purchase price can be seen only if you're an admin user. So now you can start here, exo YOLO. So YOLO is a mode that is just for demonstration purpose or during very early development, where you're saying, just create me a Postgres database, appropriately apply schema, etc., and just get me something started. YOLO is, you only live once, so don't waste any time, that sort of idea there. And then you get server started, and if you go now to your, and if I execute it, you will see that I get departments and their products. But you will see that only published products are, you only get published product. Now if you want to simulate a login, you can go and get the JW token that YOLO created and say, okay, I want to become admin. This is just for development purpose. now you get also unpublished products. So based on who you are, it will return it. So you can do based on ownership, you can do based on a variety of things. So it currently is deployable on like pretty much anything you think of, like AWS, Azure, et cetera, but also serverless environments such as Cloud Run and AWS Lambdas. But focus today is Cloudflare Workers. So what does it feel like deploying to Cloudflare Worker Exograph? So all you do is, you say exo deploy to Cloudflare CF Worker, and it will create all the scaffolding and IR file and all that thing, and essentially give you all the stuff needed so that you can do Wrangler deploy. Wrangler is a command given by Cloudflare Worker. I'll be speaking about Cloudflare Worker because that's the most experience I have, but I looked at other frameworks, and they essentially follow similar pattern with few things adjusting. So first thing we have to do is WebAssembly, we have to expose resolve function. So this is a way you want to say that if you want to resolve a particular query, call this function, and it will do whatever is needed, and that will be Rust code that will be compiled to WebAssembly. Code-wise, this is how it looks. So you have a function. You have a function resolve that takes a request and returns a response. And then you can do your typical magic inside your resolve function. You will see rather than saying extends or something, I'm using WASM bindgen. This is a mechanism where you can take Rust functions that are compiled to WebAssembly and expose it to JavaScript environments. So it will actually create a couple of things. One, it will create two artifacts. One is a WASM file that actually takes your Rust code and compiles down. And it will create a bindgen.js file, so bg.js file, that has all the glue code needed so that from JavaScript, you can just call this resolve function. So from JavaScript point of view, you don't have to now know that it's actually backed by WebAssembly, that all that thing happens magically in the glue file produced. So what was it like to port a Rust application to WebAssembly? Well, certain part, it just worked. And we were surprised, to be fair, and happily so. We thought like we'd have to work quite hard to get everything just working. So what worked directly without even us thinking about it is essentially anything to do with computation. So if it is a pure computation that takes some format and kind of does something and produces other structure, other format, those things just work. So for example, the XOR file is a binary format. You want to load it and create a structure out of it. That part just works because SERD, the serialization library, just works with WebAssembly. Parsing and validating GraphQL queries, so taking it, making sure that they follow the right syntax and the fragments are properly resolved and all that thing, that also just work because they too represent a transformation from string to a structure called query. Then mapping GraphQL to SQL. So we have two modes. So one is we do Postgres stuff, but we also we embed Dino. So JavaScript and all that thing code needs to be called. So when we do GraphQL queries to SQL mapping, that too represents, again, a pure computation, and therefore it worked, and so on and on. Some other part, we had to make some nudging around. So for example, the standard time instant is not compatible with WebAssembly platforms. So what we had to do is we had to pick up an alternative implementation called WebTime Instant. So they are API compatible, so we had to do some essentially platform-specific selection, and other than that, it just worked. Then certain parts, we kind of had to work a little bit harder. So if you want to connect to Postgres from a Rust application, typically you would do something like this. So you will say, give the URL, and you will get a PG client and PG connection. And then you will use Tokyo to spawn on that connection to do async stuff. And then you interact with your client, execute query, start transaction, commit transaction, and so on. So what we had to do in this situation is we, of course, exported the resolve function. But in this case, because WebAssembly is a sandbox environment, we had to make somebody has to help it to like say, okay, how do I deal with sockets? So in this case, Cloudflare Worker exposes an API called socket. So that we have to use. So it changes little bit. So first what you have to do is you have to use that socket to just connect it. So given a host and port, the Postgres host and Postgres port, you just connect to it. So you get a raw socket. And then you have to lay over the Postgres API. So Postgres protocol, that essentially all the stuff of bind and prepare and all that stuff, that you have to lay it over. And then you can't use Tokyo spawn, so you have to use an alternative implementation, which essentially bridges the async runtime of Rust with async runtime of JavaScript. And then it works. There were some parts where we had to actually go and contribute. So for example, Rust Postgres as it is did not work with pooling solutions that are at least available in the edge environments. So we had to actually introduce a new API. And now, but that API, this is merged. So if you now use it, Rust Postgres, this will be one less problem that you will have to solve. We had to also nudge a bit of something called OIDC JWT connector. So we allow JWT connection as well as JWKS, OIDC, that part of flow. So we had to bit of an adjustment there. Treesitter is a parser that we use that we also had to convert into Rust first, and then that made it possible. Some worker adjustment, Deadpool Postgres, which is a pooling solution. All of these things where we had to contribute a little bit. Hopefully that means if you use it now, then you few more things to deal with. So that's actually one thing that was very nice, that as Rust's ecosystem in general is very supportive of WebAssembly. So all the crates that can be compiled to WebAssembly do often end up compiling to WebAssembly. And as more and more people use Rust for this kind of usage, they contribute and its sort of ecosystem becomes better. We faced a couple of challenges. One is we had to control WebAssembly module size. So typically the edge infrastructure is laid out this way. So you have a bunch of edge infrastructure, all those 330 locations. And then you connect to a router. So when a client calls the router understands that this request is made for a particular URL, therefore it understands what code needs to be loaded and so on. So it will forward it to particular edge infrastructure, and that edge infrastructure is going to create an isolate, load the appropriate code from storage, so in our case WebAssembly code, forward the request. Then the isolate will have to compile WebAssembly or just-in-time compile, and then do the logic of whatever resolution means, and then return the result. Now, Cloudflare Worker recommends that your worker ideally fits under 1 megabyte. Now, 1 meg is not that much if you think about it. So you have to do all the things, right? Query parsing, GraphQL parsing, SQL mapping, Postgres transaction mapping, all that stuff you have to do in 1 meg. And then, well, what's the impact? So we kind of said, okay, we want to quantitatively measure it. So what we did is created a Hello World project. Doesn't connect to Rust, Postgres or anything like that. Just simple Hello World, but added a dead weight code to it. So we did not execute the dead weight code, but we just essentially had it there. And then what we found is, if you add dead weight code, it's about up to 600 kilobyte. It kind of, the cold start time is more or less the same, 200 milliseconds. But then it starts to go up. So you kind of want to manage it somewhere in that sweet spot area. So that actually imposes some architectural choices. One choice would have been, well, let's do everything in WebAssembly. So you take Exograph to combine parser, type checker, everything, as well as resolver. But that just wouldn't work because that would be too much code. We do use, by the way, sort of similar idea in a different environment, which I will talk about it towards the end. Instead, we went to just say, let's just compile down the runtime part into WebAssembly. And this is our module. So XOIR file, along with runtime, becomes our bundle, effective that, and that we try to manage. We managed it below 1 meg. So it's like 950 or so kilobytes. just about there. One thing we noticed further is if you add dead weight as in code or says dead weight as in data, there is a difference. So if you just add extra essentially bytes that runtime needs to use, but it's not a WebAssembly code, then the response is much flatter. That is to say, and that is intuitively right, because WebAssembly dead weight requires still parsing and everything to make sure that it is valid code and it needs to be dealt with, whereas data, you just load it and that's the blob, binary blob. So we are looking into some possibilities. Could we trade to make XOR bigger if we could also reduce runtime? And there is way, and the way we are exploring is to use persisted queries or trusted documents as they are called. So trusted document briefly are the document that your server declares that these are the only queries and mutation I will allow. Right to the which these are the fields to be selected, everything is locked down. Now if everything is locked down, why do we need a general purpose logic to do resolution? Right? Because right now what we do is when a query comes, we look at okay, what are the where clauses, what are the selection, etc., and let's form a SQL. So we have to plan SQL. Instead of planning, could we just do a mapping, saying, okay, here is a GraphQL query, that's a SQL. Now we cannot always do that because if we do such thing let me quickly show you one small thing. Let me launch actually. So I already have launched the Cloudflare worker. So if I connect to it, and if I go to my server, I say to-dos, then this is I'm connecting to Cloudflare worker. So that's the worker.dev URL at the bottom. Now, if I give to-do here, but let's say if I were to say give me to-dos where it's completed is false, then if I allow where clause itself to be a variable in GraphQL parlance, then there is no way for me to create a static SQL. So you kind of may have to nudge people to say, please create SQL, please create GraphQL query that are mappable directly to SQL. Some cases we can be lucky, or we at least tell them hey, if you do that route, then we will choose this kind of more expensive path. So user can decide based on what's appropriate. Couple of tools that you can use, WASM opt and WASM GC. These two tools optimize and eliminate dead code from your WASM file. There is also a tool called WASM phobia, and WASM phobia, what you do is you drop your WASM file and it will tell you who is contributing how much. And then you can kind of navigate through this flame graph and look at saying, okay, does it make sense? Do you need a replacement? And so on. Second problem we faced was external connection latency. So when a GraphQL query comes, we do the SQL mapping, and then eventually we do the connect to some data source, Postgres out there. Now there are two things. One, there's the two connections going on. One from client to the edge network. That's where GraphQL starts to shine, because in GraphQL typically you will just make one query with everything data that you need for your page. So there's not much to do because you already are making one query. But from connecting from edge to data source, you have some options, because if you, for example, do a SSL connection between your edge to Postgres, it takes 7 hops, 7 round trips to make it all work. So it's a considerable time, that it can take 300, 400 milliseconds, depending on the configuration, right? Where is your network and all that stuff. So first thing we tried, because, well, that's how we do it in non-Cloudflare worker situations, is to use application level pooling. So we use deadpool Postgres. So here it's a library that we put it in there and saying when you want a connection, go through that pool. That pool will hold on to external connection. It will hand one to you as needed. Well, that did not work, because Cloudflare worker does not like you to keep connections open between requests. And for all good reasons, because then they can't optimize. I mean, the thing is, one of the interesting thing about edge network is they do put a lot of constraints on you. In return to that, you get some other advantage. So it's a trade-off, really. So what actually ended up working is, and we tried some other solutions, but the only solution that worked is using their own pooling solution called hyperdrive. And hyperdrive is a pooling. So what happens is, when you ask your WebAssembly, give me connection, you get a connection from a local proxy, and that's very fast. And then that holds on to external connections. So difference is if you use no pooling, it's about 300 milliseconds. And again, depends on the query, depends on which database you connect, and so on. But if you use hyperdrive, it goes down to 100 milliseconds. I would say relatively numbers are right, but other than that, don't look at absolute numbers that closely. So overall experience is GraphQL fits very well into edge computing. It's already advantages of not having to overfetch or underfetch, really pays. Porting to Rust-based GraphQL server to WebAssembly was not too hard. System is evolving, more and more crates are supporting it. And some of the things I have shown you, like I had to use socket API, for example, that is very specific to Cloudflare Worker. As more standardization happen, WASI standardization happen, that will become less of a problem. So far I talked about edge as in a nearest compute resource. But the ultimate edge is the browser itself. So could we actually go and deploy all of the WebAssembly into browser? It turns out, yes. So let me show you a quick demo. So here I have a playground, and this playground, everything is running in browser. So you type in your exograph code here, and that exograph code will be compiled to its intermediate representation. So that part is happening in the browser. When you execute, that resolution also is happening in browser. And even Postgres database is also in the browser. So how does that end up working? So we actually already had a head start because Cloudflare Worker runtime part was already ported. So that was solved problem. We had to do a few more things to make sure that tree-sitter Rust to C, that part is what we had to work to make sure that the parsing happens and all the other logic happens. Other than that, it's really computation, right? You read this data and then you make. So WebAssembly fits very well there. Then XOR file is usually a file that builder builds and runtime consumes. Here we had to keep it in memory. So in browser, when we so just to show you a couple more things, like if you say it will give you errors and everything, right? So all that thing happens and it creates XOR file, but instead of creating an XOR file, we create an in-memory blob that the builder and runtime can exchange. And then the last piece of puzzle was Postgres. Postgres itself needed to be available as a WASM. And there is a solution called PG Lite, and the PG Lite just makes it available. You can just use Postgres. It's a single user Postgres that's available from the browser. So even then, it just after all that thing, it just worked. Currently, we are using the WebAssembly in browser as a playground so that you don't have to go download it if you want to play along with Exograph. But eventually, we can use it for a lot of other interesting things, such as local first computing. Because now, instead of running server, you can have an intermediate server sitting here, and that can relay changes to ultimate Postgres. So there are a lot of interesting possibilities that opens up. With that, I'm ready to take any questions. Please visit exograph.dev and check it out and let us know any feedback. Thanks. Yeah, please go.
How do you debug your WASM files? Do you face any problems with that?
Yeah, it's a good question. So the question is, how did you debug your WASM files? So pretty much, the way we end up doing is often just do the Rust debugging. And we know the path has been, usually you have very little code that says switch between WASM and Rust. So that ended up working quite well. Other than that, standard println statements and all that thing also works. There are a few things, even in println, you have to do some interesting complication because println is not directly available in the browser environment. So you have to do like a bridging to console log, and then it just works. Yeah.
I know you mentioned something about connection pooling for Postgres. I know Cloudflare workers just come and go all the time. Like, how do you deal with the connection cost to Postgres and opening and reusing connections?
Yeah, so the question is like hyperdrive itself is kind of like, it has its own cold start problem. Is that what you're referring to? Yeah. So like if your worker is like down for a very long time, then even hyperdrive connections will be dropped. So when you connect it for the first time, that would be a problem because then hyperdrive has to go and make connections and then it give you one connection. So you do actually like, have to face that problem. I talked with Cloudflare worker people and there are some things that they're working on it to keep connections live for longer and so on. So depending on your load pattern, you can kind of adjust tune some of those parameters and that will reduce your cold start time. Yeah?
Any problems with deployments and deployment pipeline?
So the question is there any problem with deployment or deployment pipeline? Not much really, because ultimately what happens is, when you deploy it, you really are creating a JavaScript bundle with WASM. So you can actually through CI, other mechanism, or just directly if you wanted to. Just essentially what we did is, there's a fair bit of scaffolding needed. So we kind of like in our XO CF build, XO deploy CF worker, that takes care of all that scaffolding. That way you don't really think more than just your domain description. And once you're done with that part, then it generally just flows. There are a few things, like if you want to do enable hyperdrive, you have to go and change configuration. So those are things you have to take. But what we do is, we kind of like did a mixed approach where we produce as much scaffolding as possible and then direct people to say, if you want to use hyperdrive, go and look at that file and uncomment code and adjust your IDs and whatnot. Yeah.
I have a follow-up.
Sure.
Yeah. Is there any issues with like, there's 330 places it has to go, right? Is that deploying nicely all at once? Is there weird offset times where clients are connecting to different edges?
Yeah, that's a good question. So essentially, like if you're deploying to Cloudflare worker, and are you thinking about versioning and all that thing as well?
Kinda, yeah.
Yeah.
You get the same client, but then now there's two different edges.
Yeah. So one thing I would say is, in general, this is a problem for even without edge, right? So Lambda, same problem will be there because there will be a potential like, you deploy to one region, but other region might not have yet picked up. One request still might be served by older version, right? So my sort of general, like, and even without like edge or serverless, even if you're just a server and you deploy, so my sort of recommendation always is make sure that you are version compatible. So do not make backward compatible changes. It's a problem anywhere you go. So for example, and that's even database schema actually have to be backward compatible. So if you keep your domain model backward compatible, so you don't then have to kind of, I know it's not ideal solution, but there is a delay though. Yeah, it will, if you deploy this thing, other one, because they have to transmit all that information and you may still get older worker for a certain duration.
Roughly how long?
I don't remember exactly, but it's not much. It's still in milliseconds. Yeah.
So, without Tokyo, doing anything interest on the server side is very hard. Like you found options to do directly getting socket, moving in other parts differently. But not everyone would have similar kind of options. Like if you were to do something on the edge or in a WASM, not even an edge, but just the WASM side. Like, what is your recommendation on? Like, the ideal thing is the WASI part with getting implemented. That's a long thing. Like it will not happen today. But what is the option to say Tokyo or something like Tokyo that you're really dependent on a normal server based thing? But if you want to convert that into a WASM, what's your
Yeah. So the question is, in edge environment, is it you kind of have to use Tokyo, or are there alternatives, right? Roughly speaking, right? Yeah. So sort of Tokyo has become the kind of default runtime, kind of for it just you reach out to this. Like for example, Rust Postgres project itself is it's a Tokyo async part is all Tokyo. So I think the Rust will have to go and make some changes itself to before you become kind of swappable runtimes, if you will. There are, I keep hearing that there are like some attempts to do that, but I don't know if it is going to happen. So until then, you kind of like, I would almost say, yeah, go with Tokyo. That's going to be the path of least resistance, really. And then ecosystem issue, right? So For example, the one I showed you, WASM bindgen futures, well, that kind of essentially like bridges the gap between those two environments, and that also itself kind of assumes the similar ecosystem. So you kind of, I think, sort of just I accept is like Tokyo as a fact of life, and let's just use it. Yeah, I think alternative async runtime makes sense if you're going for embedded or other things. So there, you have different constraints and different expectations. But for server, our kind of load, I think Tokyo is the way to go.
No, so the reason for this is like was trying to do something related to history proxy.
Sorry, what?
Like the server mesh, the service mesh can also support WASM as an option. So if you want to do certain things outside. There you may not have all these other capabilities like your cloud capabilities of software and other parts. So, but without Tokyo, I cannot have anything that is WASM working.
Yeah, I think the standardization will really help here, and I think you did bring that point where the question is only when, right? Like there's a WASM async. That's actually one interesting thing is that I kind of felt like the WebAssembly may be finally coming together all the things that is actually useful, because I for last 6 years I have been saying next year is WebAssembly's year, and so now I think though enough of standardization is like WASM, GC is coming, garbage collection, so other languages will be supported. WASI standards are coming, WASM async, that will also then it become less of an issue. So I think, yeah, I think right now that's the way we are. Any other questions? All right, I'll be around here, so we'll talk. Thanks.